Can you envision a world where computers operate at speeds currently deemed unfathomable? Let's embark on a journey through time, tracing the footprints of technological advancement. From the invention of the wheel to the creation of the internet, technology has consistently redefined our world and how we interact with it. Now we stand on the precipice of the next great frontier in technological development, the realm of the quantum. Quantum technology, a field that draws upon the principles of quantum physics, promises computing power and speed that surpasses anything we've seen before. Quantum computers, for instance, could solve complex problems in seconds that would take our most powerful supercomputers thousands of years. It's like moving from horse-drawn carriages to rocket ships in the blink of an eye. Quantum technology, an elusive concept for many, holds the key to this high-speed future. At its core, quantum technology exploits the peculiar properties of quantum physics to gain an advantage over classical technology. Now, what does this mean exactly? Well, let's break it down. Quantum technology is fundamentally based on the principles of quantum mechanics, which is a branch of physics that deals with phenomena on a very small scale, like molecules, atoms, and subatomic particles like electrons and photons. Quantum mechanics tells us that these tiny particles behave in ways that can seem very strange compared to the everyday world we're used to. One of these strange behaviors is called superposition. Imagine you're flipping a coin. In our everyday world, the coin is either heads or tails, but in the quantum world, particles can be in a superposition state, like a coin that's both heads and tails at the same time. Only when we measure or observe it does a quantum particle choose to be one or the other. Another fundamental principle of quantum mechanics is entanglement. Picture a pair of dice. In the classical world, if you roll them, the result on one die doesn't affect the other. But in the quantum world, two particles can become entangled, meaning the state of one immediately affects the state of the other, no matter how far apart they are. These concepts might sound like they're straight out of a science fiction novel, but they're very real, and they're the foundation of quantum technology. Quantum technology uses these phenomena to process information in new and powerful ways. For instance, a quantum computer uses the principles of superposition and entanglement to perform complex calculations far more efficiently than classical computers. Quantum technology also has potential applications in communication, with the promise of creating ultra-secure networks that are immune to eavesdropping. And in the field of sensing and metrology, quantum technology could lead to incredibly precise measurements and imaging techniques. Harnessing these quantum phenomena, quantum technology stands to revolutionize various sectors. Quantum technology is not one size fits all. It comes in various forms, each with its unique potential. Let's delve into the four main types of quantum technology: quantum computing, quantum sensing, quantum cryptography, and quantum simulation. First up, quantum computing. This is probably the most talked about type of quantum tech. Quantum computers use the principles of quantum mechanics to process information. They rely on quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a quantum quirk known as superposition. This means they can process vast amounts of data simultaneously, potentially solving complex computational problems that are beyond the reach of even the most powerful classical computers. Next, we have quantum sensing. This technology uses the unique properties of quantum mechanics to make ultra-precise measurements. For instance, quantum sensors could detect the tiniest changes in gravitational fields, enabling us to map the Earth's interior with unprecedented detail. They could even help detect diseases in their earlier stages by sensing minute changes in biological systems. Moving on, let's talk about quantum cryptography. This type of quantum tech uses the principles of quantum mechanics to secure communication. It makes use of a property called quantum entanglement, where two particles become linked and can instantly affect each other, no matter how far apart they are. This means that any attempt to intercept the communication would immediately be noticed, making the communication virtually unhackable. Lastly, we have quantum simulation. This technology allows scientists to simulate and study quantum systems that are too complex to study in the lab or with classical computers. It could lead to breakthroughs in fields such as material science and drug discovery by helping us understand and design new materials and medicines at the quantum level. From solving complex computational problems to secure communication, quantum technology promises a wide array of applications. Each type of quantum tech holds its own potential to revolutionize different aspects of our lives, and the possibilities are truly mind-boggling. Like any technological advancement, quantum technology too comes with its share of boons and banes. On the one hand, we have the potential for unprecedented computational speeds. Quantum computing, with its ability to process complex calculations at speeds that dwarf even the most powerful of today's supercomputers, promises to revolutionize fields ranging from drug discovery to climate modeling. Where classical computers would take thousands or even millions of years to solve certain problems, quantum computers could potentially do it in seconds. Another promising application is in the realm of secure communications. Quantum cryptography, which uses the principles of quantum mechanics to encrypt data, offers a level of security that is fundamentally unbreakable. This could usher in a new era of ultra-secure communications, protecting sensitive information from potential cyber threats. However, this coin has another side. The same power that quantum technology brings to our fingertips also poses significant risks. For instance, while quantum cryptography promises unbreakable encryption, quantum computers could potentially break the encryption codes that protect our current digital infrastructure. This presents a serious threat to cybersecurity, with potential implications for everything from banking systems to national security. Moreover, the development and implementation of quantum technology is not without its challenges. Quantum systems are extraordinarily delicate, requiring precise control and isolation from their external environment. This makes them difficult to build and maintain and currently restricts their practical use. The ethical implications of quantum technology are also a concern. With such a powerful tool at our disposal, ensuring it is used responsibly and ethically is paramount. Decisions made today will shape the quantum future, and we must tread carefully to avoid potential pitfalls. In conclusion, quantum technology holds immense potential, but it is not a panacea. It presents us with a series of trade-offs, opportunities coupled with challenges, advancements paired with risks. The future of quantum technology, thus, presents a complex interplay of opportunities and challenges. So, what does a quantum future look like? Imagine a world where diseases can be diagnosed and treated at a genetic level, where financial transactions are completed in milliseconds, and where cybersecurity is virtually unbreachable. This is the potential reality of a quantum future. In the field of healthcare, quantum technology could revolutionize the way we understand and treat diseases. Imagine being able to analyze a person's genetic makeup in real time to predict potential health risks and tailor treatments to their unique genetic profile. This could drastically improve patient outcomes and usher in a new era of personalized medicine. In finance, quantum computing could streamline transactions and data analysis, providing insights in a fraction of the time it currently takes. This increased efficiency could stimulate economic growth and innovation, creating a more dynamic and resilient financial sector. In the realm of cybersecurity, quantum technology could provide unprecedented levels of security. Quantum encryption, for instance, could make data breaches a thing of the past, protecting sensitive information from cyber threats and ensuring the integrity of online communications. But while the transformative potential of quantum technology is undeniable, it also presents new challenges and ethical considerations. For instance, the same technology that could secure our data could also be used to breach it, and the rapid advancement of this technology could outpace our ability to regulate it effectively. Moreover, there are concerns about the societal implications of such a powerful technology. Will everyone have equal access to its benefits, or will it further widen the gap between the haves and the have-nots? These are questions we must grapple with as we move towards a quantum future. Therefore, as we stand on the brink of this quantum revolution, we must approach it with both optimism and caution. We must harness its potential to improve lives and drive progress, while also addressing its challenges head-on, establishing robust regulations and ethical guidelines to ensure its responsible use. In the quantum future, the impossible may become possible, but it's a future we must approach with caution and foresight. Quantum technology, a concept once confined to the realms of theoretical physics, is now knocking on the doors of our everyday lives. We've journeyed through the intricate web of quantum tech, unraveled its core concepts and explored its diverse types. From quantum computing, promising immense processing power, to quantum cryptography, ensuring unbreakable encryption, this technology is poised to revolutionize our world. We've also delved into the dual nature of this technology, a double-edged sword that holds the potential to both empower and challenge us. It's a force that could redefine our understanding of reality, yet also pose significant ethical and security concerns. Finally, we've peered into the quantum future, a horizon filled with opportunities and uncertainties. As we navigate this uncharted territory, it's essential to remember that the potential of quantum technology is only as great as our capacity to harness, control, and ethically implement it. As we stand on the brink of a quantum revolution, the question isn't if, but when and how this technology will reshape our world.